Welcome to topic 4102, which focuses on public space and urban infrastructure for sustainable cities. The central argument of this presentation is that cities become more resilient, inclusive, and livable when public space, mobility, and green infrastructure are planned as one connected system rather than as isolated projects. In practice, this means that a street, a square, a park, a stormwater element, and a transport corridor should not be treated as unrelated interventions. They are part of the same urban metabolism. They shape environmental quality, health outcomes, social interaction, and the everyday experience of the city. Throughout this lecture, we will connect this integrated perspective to sustainability goals, planning practice, and two widely discussed best practice cases. It also invites us to think about urban infrastructure not only as a technical support system, but as a visible expression of planning priorities and public values. Throughout the topic, sustainable city planning is presented as a matter of coordination between sectors, between scales, and between immediate needs and long-term urban futures. The session is organized as a progression from concepts to evidence and then to practical application. We begin by asking why public space and infrastructure are such powerful sustainability levers. We then define sustainable urban infrastructure and examine why green infrastructure has become central to current planning debates. From there, we move into ecosystem services, co-benefits, trade-offs, governance, and indicators. Finally, we compare two high-profile interventions, the Barcelona superblocks and the Chongyiqian restoration in Seoul, to see how these ideas work in practice. The overall aim is not just to describe good projects, but to understand how cities can design, evaluate, and govern public space interventions more effectively. Keep this structure in mind as we move through the lecture, because the main concepts are meant to build toward a comparative interpretation of the case studies rather than remain abstract definitions. The case studies are therefore best read as operational examples of the conceptual arguments introduced in the first half of the session. The learning objectives for this topic are aligned with the topic 4102 outcomes. By the end of the session, students should be able to define the core concepts of sustainable development and environmental planning, explain how ecosystem functions relate to urban spatial organization, describe how climate adaptation and green infrastructure support sustainability, identify major sustainability frameworks that guide planning, and apply an ethical lens to planning choices. These objectives matter because the topic is not only technical, it is also analytical and normative. Students are expected to understand what public space interventions do, how they work, and why questions of fairness, accountability, and public value are inseparable from design decisions. For that reason, the topic helps bridge foundational knowledge with planning judgment, showing students how broad sustainability principles become concrete in urban design and governance decisions. They also signal that students should be able to move between definition, explanation, and application when responding to assessment tasks. Public space and infrastructure matter because they shape long-term urban trajectories. Roads, drainage systems, utilities, open spaces, and development patterns create path dependencies that can last for decades. If cities invest in car-dominated, fragmented, or inequitable urban forms, they lock in higher emissions, weaker public life, and greater vulnerability to heat, flooding, and exclusion. By contrast, if they invest in connected public space, active mobility, and multifunctional green systems, they create conditions for healthier and more resilient urban living. This is why 11 Sudanese pounds is such an important frame for the topic. It links sustainability to inclusion, safety, resilience, and the quality of human settlements rather than reducing it to a single environmental metric. This framing reminds us that infrastructure is never neutral. It distributes opportunity, risk, and comfort unevenly unless planners deliberately correct for those patterns. For rapidly urbanizing regions especially, these choices are crucial because the form of current investments will shape future vulnerability and opportunity. Sustainable urban infrastructure should not be understood as a narrow bundle of physical assets. The literature frames it as a socio-technical system that includes material networks, service delivery, governance structures, and social outcomes. Water systems, energy systems, transport networks, sanitation, digital systems, and the built environment are all part of it, but so are the institutions that manage them and the communities that rely on them. This broader definition is crucial because infrastructure success is not measured only by technical efficiency. It is also measured by reliability, adaptability, accessibility, and distributive fairness. In other words, sustainable infrastructure is not simply infrastructure that functions. It is infrastructure that functions in ways that support long-term social and environmental goals. This broader lens is especially useful for sustainable city debates, where the challenge is not just to build more infrastructure, but to build systems that remain socially legitimate and environmentally robust over time. As a result, planning for sustainability requires attention to institutions and users, not only to construction and technology. A major theme in the presentation is that public space quality must be assessed through inclusion and equity, not aesthetics alone. Access means more than physical presence. It includes proximity, connectivity, affordability, and universal design. Comfort includes shade, thermal relief, seating, visibility, and perceived safety. Social value includes whether a space enables play, encounter, rest, and belonging. Equity asks whether these benefits are distributed across neighborhoods and population groups, or whether investments reinforce existing inequalities. This perspective is especially important because some urban improvements can unintentionally concentrate benefits in already advantaged areas or trigger displacement pressures. Good planning therefore requires both place-making and protection against unequal outcomes. A technically attractive public space that excludes some users, overheats in summer, or becomes unaffordable through surrounding change cannot be considered a fully successful sustainability intervention. This is why the lecture repeatedly links public space design to justice, accessibility, and everyday experience rather than to beautification alone. Inclusivity also has a communication dimension. A communication-friendly public space is one in which users can orient themselves, understand one another, and participate comfortably in social life. This includes design for legibility, clear acoustic conditions, visibility, reduced sensory barriers, and opportunities for different groups to use the space without exclusion. The significance of this point is that access is not only about ramps and sidewalks. It is also about whether a space supports meaningful interaction for children, older adults, people with disabilities, and diverse language or communication needs. This expands the idea of inclusive public space from a physical access concept to a broader social and communicative one. In other words, a truly inclusive space is one that supports both physical use and social participation in everyday urban life. Communication-friendly design can therefore be understood as part of social sustainability, not a separate specialist concern. Green infrastructure is often treated as a familiar term, but the literature shows that it is highly variable in meaning. That is why it has been described as a green chameleon. In some contexts it refers mainly to green space planning, in others to urban ecology, and in others to water management and stormwater systems. The key lesson is not that the term is unusable, but that planners must define it explicitly. If one team imagines habitat corridors, another imagines bioswales, and a third imagines recreational parks, they may all support green infrastructure in theory while pursuing very different objectives in practice. Clear definitions are therefore essential for project design, stakeholder coordination, and evaluation. When definitions remain vague, evaluation becomes difficult, stakeholder expectations diverge, and cities may overclaim what a project will actually deliver. Explicit definition is, in this sense, a form of planning discipline and a precondition for credible sustainability assessment. Once defined, green infrastructure should be understood as a multi-scale network rather than a single project type. At the site or building scale, it may include green roofs, green walls, rain gardens, and permeable surfaces. At the neighborhood scale, it may involve pocket parks, street trees, bioswales, and connected pedestrian routes. At the city or regional scale, it may include river corridors, habitat networks, urban forests, and linked blue-green systems. Seeing green infrastructure across scales helps planners avoid fragmented thinking. A small intervention can be valuable, but its full performance often depends on how it connects to wider mobility, water, biodiversity, and public space systems. This network perspective also helps cities prioritize connectivity, which is often more important for long-term resilience than the symbolic visibility of any single flagship project. Multi-scale thinking also improves sequencing, allowing small interventions to be designed as components of wider urban transitions. The ecosystem services perspective explains why green infrastructure is so attractive in contemporary planning. Ecosystem services are the benefits that people obtain from ecosystems, and in urban contexts these can include cooling, stormwater retention, air quality improvement, habitat support, recreation, aesthetic value, and mental health benefits. The presentation also emphasizes co-benefits outcomes that extend beyond environmental performance into public health, comfort, and social well-being. This is important because it shifts the planning conversation from single-purpose infrastructure to multifunctional urban systems. A well-designed public space intervention can reduce heat, improve mobility, support public life, and contribute to local identity at the same time. The ecosystem services framework is therefore most useful when it is tied to explicit place-based objectives rather than used as a general promotional label. Co-benefits become most convincing when they are connected to clear causal pathways and monitored after implementation. A recent review of urban green infrastructure identifies 6 recurring themes in the literature, and these themes help us organize the evidence base. The first is ecosystem services and environmental functions. The second is climate adaptation and risk reduction. The third is public health and social co-benefits. The fourth is governance and implementation. The fifth is planning, design, and evaluation. The sixth is equity and access. Together, these themes show that urban green infrastructure is not simply about adding vegetation. It is about creating systems that are legible, governable, maintainable, and socially beneficial. For students and practitioners, the value of this synthesis is that it provides a structured way to think about what must be balanced in real projects. For teaching purposes, these 6 themes also help students see that technical design, governance, and social justice belong in the same conversation. They also make clear why no single discipline can adequately explain the performance of urban green infrastructure on its own. At the same time, the literature warns against green infrastructure optimism. Green infrastructure can generate disservices as well as benefits. Poorly chosen species may increase allergens, some interventions may increase water demand, maintenance failures can create safety or cleanliness problems, and benefits may be unevenly distributed. This is why maintenance is not an optional afterthought. It is a core component of planning. A project that looks strong on paper may underperform if there is no long-term capacity for care, cleaning, repair, and monitoring. Good planning therefore requires explicit discussion of trade-offs, life cycle responsibilities, and the potential mismatch between design ambition and governance capacity. A sustainability intervention should therefore be judged not only by its opening day image, but by how it performs through time under real conditions of use and care. This is also why trade-offs should be communicated transparently to the public rather than hidden behind generalized sustainability language. Another key takeaway is that sustainable cities require integrated green, blue, and gray infrastructure rather than one-dimensional solutions. Green systems such as tree canopies, parks, and bioswales should work with blue systems such as waterways and stormwater networks, and with gray systems such as transport, drainage, and utilities. This integrated perspective matters because urban problems are interconnected. Heat, flooding, access, land use, and mobility cannot be solved by isolated projects. Planning should therefore focus on how different infrastructures support one another. In practical terms, this means that nature-based solutions should be embedded within broader urban service systems instead of being treated as decorative additions. This is one reason why public space planning benefits from interdisciplinary coordination among planners, engineers, ecologists, public health specialists, and local communities. Integration is therefore not only a design principle but a governance principle that shapes coordination across departments and budgets. The presentation translates the literature into a planning workflow that starts with explicit goals. Step 1 is to define the outcomes being pursued, such as cooling, flood mitigation, social inclusion, biodiversity, or active mobility. Step 2 is to choose definitions and intervention types that match those goals. Step 3 is to map risks and opportunities across the urban area. Step 4 is to co-design interventions with communities and users. Step 5 is to implement with clear roles, budgets, and maintenance plans. Step 6 is to monitor outcomes and adapt over time. The strength of this workflow is that it connects evidence to action. It also reduces the risk of vague sustainability claims by insisting on measurable intentions and accountable delivery. It also encourages cities to treat sustainability as an iterative process of learning and adjustment rather than a one-time design exercise. In educational terms, this workflow helps students move from abstract principles to a repeatable professional method. Evaluation is most useful when it is multi-benefit and multidimensional. The presentation therefore recommends a basket of indicators rather than a single success metric. Environmental indicators might include temperature reduction, runoff management, canopy or permeable surface coverage, and habitat quality. Health and social indicators might include walkability, perceived safety, comfort, access, and use by different groups. Mobility indicators might include traffic reduction, pedestrian activity, and cycling uptake. Equity indicators might examine where investments are located and which communities benefit. This approach is more demanding, but it better reflects how public space interventions actually operate in cities. Urban success is rarely one-dimensional, and evaluation frameworks should reflect that complexity. The point is not to measure everything indiscriminately, but to choose indicators that reflect the intended outcomes and the communities most affected. This is especially relevant when cities need to justify investments under budget constraints or competing political priorities. Ethics and governance are not side issues in environmental planning. They are central. Every public space intervention raises questions about who decides, who benefits, who pays, and who may be excluded. Participatory planning is important not because it guarantees consensus, but because it improves legitimacy and helps surface local knowledge, competing needs, and hidden barriers. Governance also matters after implementation. A project needs institutional responsibility, maintenance budgets, and performance expectations. Without these, even high-profile interventions may lose quality over time. The ethical message of topic 4102 is therefore straightforward. Sustainability must be pursued with attention to accountability, inclusion, and distributional justice. Sustainability claims are therefore stronger when they are paired with transparent decision-making and mechanisms for ongoing public accountability. An ethically informed planner therefore considers not only physical outputs, but also procedural fairness and long-term social consequences. Before turning to the two case studies, the presentation proposes a common evaluation lens. This lens asks 6 questions. What was the core intervention? Which sustainability problem was it addressing? What outcomes were targeted? What co-benefits emerged? What governance or implementation conditions mattered? And how transferable is the model to other cities? Using a common lens is important because case studies can easily be reduced to celebratory storytelling. Comparative evaluation keeps the analysis disciplined. It allows students to identify what is generalizable, what is context-specific, and what kind of evidence supports the claim that a project should be considered a best practice. With that lens in place, we can now examine the cases as planning lessons rather than isolated success stories. It also helps distinguish transferable principles, such as integrated planning, from place-specific features that cannot simply be copied. The first case is the Barcelona superblocks model. The basic idea is to reorganize traffic so that through traffic moves around the perimeter while the interior of the superblock is reclaimed for people-oriented uses. This redesign creates space for walking, cycling, rest, play, greening, and neighborhood life. The case is significant because it shows how a mobility intervention can also become a public health and public space intervention. By reducing traffic pressure and reallocating street space, the model supports environmental quality, social use, and safer everyday mobility. It is widely discussed not because it is a universal template, but because it demonstrates the power of street reallocation as a sustainability tool. The model also reminds us that the street is not only a transport corridor, it is one of the most important public spaces in the city. Barcelona shows that reducing vehicle dominance can be a spatial, environmental, and social strategy at the same time. The second case is the Chongyicheon restoration in Seoul. This project is used in the lecture as an example of reclaiming an urban waterway and transforming it into a public space and ecological asset. Rather than treating infrastructure only as traffic throughput or land development support, the intervention reframed the corridor as a place for environmental recovery, public access, and improved quality of life. The case illustrates how restoring blue-green systems in dense urban contexts can generate broad symbolic and practical value. It also shows that environmental planning is deeply tied to identity, public perception, and the lived experience of urban space. At the same time, the Seoul example reminds us that restoration projects are complex and must be interpreted in relation to local political, spatial, and economic conditions. Seoul shows that ecological restoration can function simultaneously as environmental repair, spatial restructuring, and public space renewal. In summary, Topic 4102 argues that sustainable cities are built through integrated systems thinking. Public space, mobility, and green infrastructure must be planned together, with explicit definitions, measurable goals, and strong governance. Green infrastructure is valuable because it can deliver multiple ecosystem services and co-benefits, but those outcomes depend on design clarity, equity awareness, and long-term maintenance. The Barcelona and Seoul cases show that reallocating urban space to people and nature can produce meaningful sustainability gains, yet transferability always depends on local context. The practical lesson for planners is to move beyond isolated projects toward coordinated, inclusive, and evidence-based urban transformation. Together, these ideas support a more rigorous understanding of sustainable city planning, one that connects environmental performance to social quality, public governance, and everyday urban life. For students, the key message is that sustainable urbanism succeeds when environmental intelligence is matched by institutional clarity and social responsibility.